Så känner man faktiskt pigg för första gången på länge.
Okay, so let's get started. So here's the so my Twitter consumer key, consumer secret token, and token secret are already launched from definitions here. So if you have yours ready, you can put them in this thing. And now I'm going to just create a Twitter stream for the input source, right? So I have to create my auth immutable, which is just a new of the OAuth, authorization tools from the Twitter 4J thing. And then now what I'm going to do is, so the code we brought in 025_a extended Twitter utils. So I'm basically calling the method create stream in that code, right? For now, just think of it as all you need is a Spark streaming context as input and your Twitter authorization OAuth credentials. So now it's simply going to create my Twitter stream. Okay, we'll get back into this code soon. So now what we're going to do is map, so the raw streams will be coming at us in this Twitter stream once I start it. Right now, I've just initialized it. But we want to be able to see it in a human readable way. So we will use this JSON, which is a JavaScript object notation. It's a sort of human readable, language independent way to store information, right? So you can have keys and values and nested layers, and so you can essentially have pure text, pure strings in a certain format that will allow you to get into things. So we'll see examples of JSON. So this is why we imported the Google's JSON library, JSON. So what I'm doing now is a transformation. So I'm taking my Twitter stream that I just initialized, and I'm doing a map. In the map, I have X, whatever is coming at me, the tweet, the raw tweet, and then I have a closure here, right? So recall from like first week, the closure, anything inside the closure is serializable, so it can go through the Ethernet cables and back into memory. All of that is taken care for you. So that's why we do it like this. And so I basically create my immutable JSON as a new instance of GSON, Google's thing, and then I just make my XJSON, which is just JSON.toJSON method I'm calling on X, right? So and then in Scala, if I just leave XJSON as the last thing, it will return it. So X becomes XJSON now. Okay, so let me initialize this, and you will see that this is a, so if you see the types, it's dstream, discretized stream, is what's coming back at you as strings, okay? So now, because JSON is just string. So now what I do is I initialize a bar, a mutable type so type in first as a long, 0L, so just a long integer, initialized at 0 for the number of tweets collected. And then partition each interval. This is just a little val that I take as 1. So this is, you'll see it gets used later on, how I'm doing my repartitioning. So what I'm going to do is take my Twitter stream JSON, this thing here. So, and then for each RDD in this discrete stream, so you see for each RDD is this thing. It's a tuple where you have the discrete the RDD and the at time TIME, right? So these are your little discrete RDDs. So then what I do is I take that ordered pair and map it like this. So this is my closure here. So for each RDD in the D stream, I first count how many elements are there in the RDD, right? So this is the number of JSONs, which are just the number of tweets in JSON format. And then I say if my count is more than 0, if there is actually a tweet, then I do the following, right? So what do? I basically say output RDD is take my RDD and I repartition it into 1, right? So I basically have one partition of all the RDDs. So hopefully I have to choose my time units so that I don't, put a very large number of tweets in one partition, but I sort of to be slightly careful. But yeah.
So the RDDs can be distributed in this way, so push them together into one machine.
Yeah, we're putting exactly into one partition, which will be in one. Yeah,
right.
Exactly.
But before this, they can be.
Yes, absolutely.
Right. And after, it can also be all over the place.
Yes, it can be. Yeah, that's right.
So that's one step we push together, and then in the next step, it can be all over the place.
Yeah, when you read it, it'll be all over the place. But you can also write it with money partition. You'll see why I'm doing this, because I'm keeping my time interval small, because I want to write the files quite soon using, there it is. So I'm going to, I want to take the reason I collect everything, as long as it's not too big, is so that I write the output RDD, okay, to a text file with my output directory root concatenated with just sub directory called tweets underscore, and then I have my time in milliseconds to string. So I want to basically collect the time at which I write in milliseconds as the directory name, okay? And the reason is just you'll see later, we'll expand on this and put the year, month, date. So I have a time hierarchy of files, which I can use later on in various key value stores if I'm collecting for a long time. That's the reason I'm doing this repartitioning into one for this example, right? So it's mainly because I want to write everything I'm collecting at this timestamp to one file, to one directory.
If it was still partitioned over multiple machines, it would be multiple directories.
Yes, or it can also go into the same directory.
As different files then.
Yes, it'll have more than part 0, part 1, part 2. Yeah. So, okay. But I'm kind of doing it. You can. Okay. If you have a big load and you want to write in parallel, then you can have more than one partition. That's okay too. Okay, so nothing has actually happened yet, right? So, right. So I haven't evaluated this. Okay, so nothing has actually happened yet. So we have to start the streaming context, right? And I am just slightly paranoid. So I go here and I look at the Spark UI and make sure there's no Spark streaming running. Good. So I'll just come back. Yeah. So now. Okay. Okay, so now I'm going to start, and I can see how many tweets are collected so far. Nothing. Oh, that's great. Did I? Yeah, I don't know. Maybe I'm doing something wrong. It was working earlier, so let's see.
It takes some time.
Oh, it takes some time?
Yeah, I tried.
Okay, oh yeah, it depends on the time. So 1 second, yeah. So I collected like 187 in like 3 seconds this morning. So, but is anyone else you're collecting?
Yeah, I'm collecting.
Yeah, okay, good. So that's good. I'm not collecting. So that's the other thing as well. So it's not, nobody really knows except Twitter, like what's really going on with the public streams, because you're supposed to be collecting up to 1% of all the tweets. Okay. But then the exact subsampling procedure is proprietary, like we don't know. And the interaction of the subsampling procedure when lots of people are collecting the stream from IP addresses that are in the same place is all proprietary. So I don't know.
So how do you debug here in Spark?
Debug?
Yeah, but it's not working.
What is debug?
Debug.
Oh, debug. Sorry. Yeah. So I don't know. So let's see. I want to make sure. Let me just make sure that I actually entered all the cells. I'll show you. I can definitely try. one more time. If it's still 0, then I think we have to debug. Okay, so let's see. So to debug, I can go here and then look at my Spark UI here, and then look at the streaming, see if I have some. So here is a. I actually don't have any errors. So I did try 141 completed batches, but I have 0 records. So
do your authentication fail or something like that?
It could, but that it'll usually come here as an error message.
Okay,
that happens. So I mean, okay, but let's maybe go quickly if some of you are seeing it, because I really want to get to some other things, because we spent all of yesterday on other things. So okay, so you would want to stop this when it's running, and then you can do this to basically loop through all of them. And so last time I did this morning at 8:30. This is actually what I collected. So you can see the tweets with the timestamps and the directories, and then I evaluated this. Then I can basically find, I just basically took one particular, so you can copy one particular timestamp. You have to change this because it'll change. Then you will get your tweets directory. And then I just listed what's in there. So this is a question you asked, like, because we said only one partition, so I only have part 000. So this is the distributed file store under the hood, and the number of partitions are reflected here. And it had a large size, and then I counted. There were 36 tweets in that file. So multiple partitions. You can count each one if you like. And then I just converted that into a JSON. I turned it to a data frame basically with SQL context read JSON, and then I printed the schema. And this is actually what's in each tweet, potentially in each tweet. As you can see, there's a lot. Video aspect ratio, URL of the video, coded status, in reply, blah blah blah. There's a lot going on, right? It's just each tweet. So there's geographical information, user and who was mentioned, and so on and so forth. So then I actually just selected the ID and the text, which is the tweet text, and I'm showing everything. So then I don't know. This is the ID of the tweet. So each tweet has a unique ID. This text says 1 person followed me and 2 people unfollowed me. Whatever. This is random people saying something at 8:30 this morning or 8:27. Oh, look at this. This is cute, right? So some Thai. It looks like Thai. And some Japanese, I think. Or yeah, looks like Japanese. So I don't know.
And someone who is sick.
Someone.
Face.
Oh, really?
I'm sick all day. That face.
Oh yeah, cool. We're sad about it, right? That's
Poor person.
So then I do display out JSON, right? And then you can see this way, right? So this is kind of exhaustive, right? So this is a lot of information. And so I've been spending actually several months formalizing these as mathematical objects, as binary trees and networks and fully overloaded objects that you can encode in data frames and GraphX. So, and then I just removed this, yeah. So you want to do this just to keep it clean, so you don't waste your space, okay? So what we can do with tweets is a lot. So especially if we have a bit more under our belts, like natural language processing a little bit more, maybe beyond the word counts and bag of word models, maybe a little bit of sentiment analysis. I wouldn't really call this natural language processing, but it's something with strings, but a little bit better than just counting words. Then you can do, say, you already know a bit about distributed vertex programming, and we went through the whole programming guide for GraphX. So imagine you can actually have in your stream, you can have like stuff, or you can just save things to the disk and then overload everything that happened in some latitude and longitude over some time frame, and then take all of that and start processing it using GraphX, okay, or graph frames, and doing stateful queries. For example, you can concretely ask things like, who next to coffee shops in this part of Manhattan said they have a headache, and while they had at least 80 followers. This is actually a stateful query from GraphX. It's just a few extra couple hours of work on the syntax you already know from last week. Okay, so these kinds of queries are very, very straightforward. Now, what you can really do, some more magical things you can do is if you can take the location of the tweeters, which is about a third of the tweeters, at least in the US, have geolocations. And then you can map that to OpenStreetMap. So this is non-proprietary OpenStreetMap, not Google Maps. And then you can start doing arithmetic with spatiotemporal trajectories. So there's a whole thing. Hopefully, I'll try to get to it before we break. That was my plan for next week. So then we can do this sort of scalable geospatial computing. So we can ask, give me everyone in this polygon. So for example, there was a march between fascists and anti-fascists in Gothenburg last weekend. You can ask real-time queries. Anyone can, you can say, here's my lat long on this location and this location. I want to monitor live for possible escalation from a security perspective, or whatever you want. Okay, you can do some NLP on sentiments and things like this. So this is people doing stuff like this all the time. Okay, so then here is basically making a function for Spark streaming. So instead of doing all of these things step by step, we can do the following. We can say, here's my output directory, is my batch interval. So I've changed this batch interval in units of minutes now. And it's my timeout, which is basically when to stop the job. It's probably what happened to me. I probably, for 5 seconds, nothing arrived in my case, and then it stopped automatically, I think. So that probably happened for me. So, you may want to extend the timeout period. So here we now, once again, have the same things. We initialize number of tweets collected so far. But now, see, I'm basically putting all these little boilerplate things into one block. This is my function now. Okay, so it's a lot going on in this function, but not really, right? So I'm basically defining a function. It returns a streaming context. I'm creating a mutable streaming. So this is exactly the different pieces we've seen, but we're all putting everything together now, right? It's the mapping JSON, partitioning interval for each RDD. See, now I'm doing slightly nice things, right? So I want my timestamp not just by milliseconds. I say year, month, day, hour, right? So now I can just create a nice file structure like this. So I'll basically have the year, month, day, hour, and then the millisecond of the write, right? So that's a unique labeling scheme. And if I run this, so now I can just have one function that just says SSC is get active or create, or I simply pass in the stream func to it, right? So this is de-boilerplating it, right? So it's nice because it's modular and I can control it and I can start again. And so let me try this. Oh, crap. I should actually stop first. So let me try this. So let's see. So I should go and look here, see what's happening. So I'm running batches of 1 minute now. Only 9 seconds has elapsed. This should again work for you guys. So now I'm collecting, you should get about 30 tweets per minute from the public, freely available streams. Okay, so, oh yeah, now I'm collecting 1080 records. So I believe what happened, Amrita, is that I think nothing happened for me by chance for 5 seconds. Although this is a great test, right? Although you guys, if you clicked almost at the same time, you got some tweets, so your collector was going and mine just. So there is some proprietary thing on exactly how the 1% is available to different people. Okay, so now we have, 1 minute. So if I do it for 2 minutes, you'll start seeing a little chart here. So let's keep this guy running. So then see what's in here. Right, so that's my directory. So what you want to do is start increasing this. So I just put 2017. Then I'm going to just keep adding October. Today's already 5th. Oh my God. And then 9. Oh, I guess it's running on whatever time. This is Oregon time, I guess. I don't know. Java utils dot date returns. So and then you can now you see there's 2 minutes collected. So let's just do this for sanity check. Yep. See, I've got 20 records per second, and now it's up to 30. And if there is actually like a Twitter storm, this will go up. I've seen this go up to 60, 70 per minute, right? Which means like so it does go up with the global volume of tweets, but of course it's a random sample. Now, random samples are great, but we want to do a bit more, right? Okay, so I'm going to kind of crash through this. So what I'm going to do is now, I've got my tweets sitting beautifully there for me. One more detail maybe I should say is this one. Okay, I'm writing, you see what I'm doing is I have basically this JSON string, right? What I'm going to do is take this JSON string and turn it into a Parquet. I turned it already into a data frame. Now I'm going to write that in Parquet, right? Remember, Parquet comes from this Dremel paper from these guys, Google and so on. So now we're going to write in this efficient format. I'm not like very good at anything actually, but the only thing we could not break when the schema of Twitter was evolving was just to write these raw tweets as JSON in a single column Parquet format, okay? So that, when we read it later, we can read directly from this. But the beauty is if Twitter introduced new schemas, like new fields for whatever reason, or changed the meaning of older fields or dropped some old fields, then you see we can still read in a sort of future, time agnostic way. That means, remember when you read the Parquet file into a data frame, what's going on actually is, if it's a very large file, then your the reader will actually go and do a very thorough sampling of enough JSON of the JSON files and figure out the schema dynamically as it's reading, right? That's Spark SQL doing it freely for you. Which means like if there's schema mutations in the time window at which you're sucking all the stuff, then it's okay because you basically read it twice. That's the breaks, but you can get you can automatically infer the schema. So I'm sure like the proper software engineers will have a much better solution than what I'm doing, but for us it's good enough. Okay. Right, so now what I wanted to do is run this function. So remember, this is O25_B, which is this TTTDF. So this is the tweet transmission tree. So it's actually a, kind of a formal object. Well, okay, it's very complicated, but the simplest possible instance of it is mathematized reasonably well. So if you want to understand how we came up with the functions in this file, right? You want to look at that notebook. It's just Apache 2 licensed, and it just has very simple, so this is the usage. You just basically do tweets data frame to TTTDF, and you will, what's the input to it? It's tweets JSON string data frame to tweets data frame from Parquet file to DF and the name of the Parquet. Just everything, the function name is what it does. But if you go into this particular notebook here, you will see what what are the functions we're actually calling. So there's no magic here. Okay. This part is kind of hard work, but it's not magic, and we want to be completely transparent about how we are calling a tweet, a retweet, a reply tweet, or a coded tweet, or a retweet of a coded tweet, or a reply tweet of a coded. So there's a whole taxonomy of what a status update is. And this, again, in the literature, in network science and computational sociology, and there's a whole data science institute at Columbia University. So they all these researchers call things to be retweets or reply tweets, and in a not in an unambiguous way. So this was our effort to like make it very standard when we are doing research. So if you disagree with our definition, you can change it, and then we just checkmate against each other using the latest Twitter developer docs. Okay, so it's quite complex. We just get the Unix timestamp, but it's just pure SQL, and we do lots of so these are fields in the JSON key value things, and you have to figure out what you. So then there's quite a lot of logic here, right? When the original tweet ID in retweet is null and the original tweet ID in quoted tweet is null and the original tweet ID in reply is equal to -1, then it's an original tweet. You can challenge this. We can wage war on GitHub and mathematics, right? But that's the breaks. So if you believe this is sensible, and this is not magic again, if you go and descend into this notebook basically gives you how we did the tests ourselves. So I basically had my own account and my daughter's accounts and my grad students' accounts, and we were actually just tweeting to each other and retweeting and making sure that when we did this, everything was caught. So it sort of explains how we reason about it. Okay, so it's not you have to read a lot of docs, but I hope Twitter hasn't evolved a lot in the last few months. Okay, so we just have screenshots of what we did and how we develop the logic, so it's all incremental. Okay, so, but let's just kind of get back to doing something concrete. And that's just sort of academic backing, right? So now what I can do is, where were we? So, right, so we were in the bottom here, right? Yeah, so I was about to run the TTTDF, the tweet transmission. So that's just for DataFrame pipelines. Okay, so here we go. So yeah, Kinwande Atanda is this grad student from New Zealand. He's actually from Nigeria. He's a pretty hardcore guy. So he did a lot of the coding. So here is basically what we did. So I'm basically now doing star. So I want to read everything. So let's see, my collector is still running, I think. So let's see, let's check how many directories are there now. So the date hasn't changed, hour hasn't changed. Okay, so we see there's more files. Yeah, so we can read it. So I'm just from Parquet file to DataFrame, and then I'm saying my TTTDFs or tweet transmission trees. DataFrame is just this thing. So now let me count. So with that action, the DataFrame will be cached. So although it took 4 seconds, they should take less than 4 seconds now. Yeah, because it's cached after the first action. Now I can display this. So this is a lot less information than the raw tweets. Remember, the other thing was just crazy with like video streams and blah, 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 blah. So much information. So we just picked some things, okay? So here's current tweet date, current tweet ID, creation date of the original tweet in the retweet, and a lot of information. So C post user ID. So let's look at this. Okay, is geo enabled, current tweet. So here's the tweet type. So this is actually a retweet. So and the second one is the original tweet. So a retweet is when you just basically retweet a tweet. So you sort of don't do anything. You don't add any extra strings or anything. You just sort of spread the message. So yeah. So this guy is, so it also says in the tweet text itself, RT for retweet. And these are just some Twitter screen names that are mentioned. Tutu Kagabian, no idea. Something in Japanese, the original tweet. Okay. Boku. Well, I don't know, man. Yeah, well, actually, what'll be awesome if people are into NLP and you want to really get into the muck with yourself, and I would love to join in, is we should tap into this Google. They have this thing they built, right? Multilingual deep neural net technology, right? It's zero-shot translation, so you can put anything in and it'll come out in any other language. Do you know about this? Right? This was in the news a couple months ago, and I believe that's free. In fact, I have pointers to that. So if we can actually get this thing, or maybe make API requests to Google, black box it, and then we can pump all these strings in and get the same stuff in all the different languages simultaneously. Because they kind of claim to have invented this universal language that's this thing, right? So you can kind of start mapping in that space and do some. It's all bullshit anyway, but it could be fun. Okay, so this is, I'm just grouping by tweet type and ordering the count and descending. So we see the retweet is 8,401 in this example, and original tweet. So retweet is the most popular type of status update in Twitter. There's also retweet of a coded tweet and a coded tweet. So for reply tweets, it's very difficult to do anything just without the text. You really need to get into the text, because I can reply and say, screw you, or I love you. I can say, so you have to see what's the context. The same with coded tweets are even more deadly, because I can, Hillary may quote Trump and say, isn't he an idiot, or whatever, right? Or vice versa. So then you need NLP, natural language processing, even some crude sentiment and something, right? And there are libraries that specialize in this, like there's guys at Carnegie Mellon that have special library for Twitter semantics and so on. But that's a bit beyond my, so I'm just going to stop the job because I don't want it to keep running, and I'm going to just clear out that directory because I don't want to really deal with it. Okay, so now I just will mention this. So often what you will want to do, especially if you're in the community edition, is maybe you still want to play around. You don't have enough resource to buy the academic shard, or your advisors don't, whatever. So you don't have the commercial grade, so you still want to play around. Then maybe you can pay a tiny bit of money to AWS, because Uppsala is an AWS Educate member, so you guys automatically get $100 or $200 for free. But I think you still have to use your credit card. So anyway, yeah, be careful, right? Because you can just blow up your credit. But storage is very cheap. So you can actually start doing a little experiment and put your stuff in S3 in Amazon. Amazon's S3 is simple scalable storage or something. It's a distributed file store, proprietary. It's like Hadoop-ish. And from Databricks, you can write to it. And from Spark, you can directly write to it. So there are the connectors to all these different proprietary stores, distributed stores. So this is just the syntax for it, right? You have to go to Amazon, get your S3 credentials, and just put it here so it can save you a lot of time. It took me a lot of time to figure all this out. So how do you copy? How do you mount? So once you mount the file store from Amazon, then you're done. It's just like a DBFS access. It's like so you can use all the DBFS utilities directly on the mounted thing. Okay. So now let me quickly get you guys into the next one, which is going to let you design your own Twitter collector. Because what we did before was just tap into the public stream. So what? There's some Japanese and Chinese and Korean, whatever. It's some random, people all over the world, right? That's okay in some ways, but it's kind of not that interesting. What you want to do is be able to design a Twitter collector to capture live tweets that maybe, say, is tracking a list of strings of interest to you, like Make America Great Again or whatever, make data science great again. Or you can also at the same time choose to follow a list of specific users. So you have to find their Twitter IDs, which is fairly straightforward. Once you have the list of Twitter IDs, then you can just do this, right? So I'm going to show you how, on the extended Twitter utils we already have, which is just this load, this run. So it already has methods for this. We currently don't have geospatial stuff yet because I'm, scrubbing can be done, but I currently don't have, or Ivan Sadikov, we might implement it. Let's see. So now I'm just importing the same TTDDF, so I can do all my transformations into the fewer fields into a nice data frame. And then I'm just paranoid. I want to stop all the context again, streaming. So now I just load my credentials here, and now you guys don't have this file, but I actually have this file of because we were monitoring the British election recently, so we had like all the members of parliaments and politicians of interest, various common newspapers in Britain, political bloggers, and so on. So we kind of have this CSV file. I can share that with you later if you want. And then, so this won't work for you yet. And then I'm just turning that into a Scala list buffer. So this is a whole bunch of longs, integer long ID. So this is the Twitter ID. And then I'm basically going to extend, use some more inputs to that function. So here it is. This is all the same as before. And the only difference is now here. So I have something called track. So this could be arbitrary strings. So we can try. I'll see if we catch this live. Maybe it'll be a good day. So I'm now putting some arbitrary strings I want to catch, and then I have my list of files I loaded, people I want to follow from the British election. And then I'm simply putting, just like before, we only had SSE and auth, which means track and follow are default empty. So we weren't tracking anyone in particular or following anyone or tracking any string in particular or following anyone in particular. Then it's the global. But you can put these things in. So the cool thing is you can still get technically up to 1% of all the tweets, as far as I understand, which means if you can zoom in on something of interest, you can get a lot of information for free. So that's all we're doing here, and everything else is basically the same. So let's see if this will just work. So you can put you can put your own Twitter ID if you want, or Trump, or whoever you like. Okay, so let's just check out what's going on. So this I already stopped and restarted. So this is running batches of 1 minute for, so we'll see. So these IDs correspond to some British politicians. So, I don't know what will happen live, but let's just give it a sec. Yeah, so once it loads, then you can kind of start seeing let's see if there's any activity at all. 109 records. Okay, so England is it's daytime there, right? So it makes sense. So this is going to be, we should be able to see something in the next minute. Let's see. 2017, 10. Oh, it's still the 5th, right? Okay, so yeah, so you should have, okay, so it's only collected one so far, but let's just grab 026, what is it? Yeah, I'm just trying to grab something.
What was the difference between the track and the follow?
Oh, sorry, what's the difference between what and what?
Track and follow arguments.
I think it's Russian. Well, Ivan is Russian, right? So he says track means track some strings, and follow just means follow any status update that was that's related to these people. So if these people with the user IDs either tweeted or someone retweets them or replies to them, all those status updates will be in the follow, will be collected.
Okay. So it will actually look for the union of the two. Right?
Yes, exactly. That's cool. Yeah, that's right. So I technically should be able to add the geospatial stuff, but let's see if I first get to the scalable geospatial computing, and then we'll try to maybe extend it further. So anyway, if you, I'm just trying to find the syntax for the TTPDF. So maybe I put it here already. Yeah, maybe let's try this. All right, so I need yeah, I'm just trying to copy this. So I kind of ran out of time, you know, so to make the, so let's see, Control V. So is this still the name? 20, yeah, no, let me just make sure. I think it's the same. 10.05.09, 10.05.09. Control V. Oh, no, so that's correct. Okay, so I think that looks good to me. What do you guys think?
Yeah.
And then let's just display. 2 minutes late. So okay, this should be about something that's happening in Britain right now. Oh, politicians and stuff. So Telegraph News. That sounds good. Yeah. So terminally ill man loses High Court challenge against the law on assisted dying. So you see that URL. So I have a current student that's finishing masters. So we've been also taking the URL entities and constructing formal notions of information networks that are on the Twitter network, right? Because those URLs, you can go and mine the articles and do a lot of stuff. So we're sort of, currently we're not doing any NLP again, we're just formalizing mathematical graphs and networks for flows of information. So we know the limits of manipulatabilities, you know, like, which is the games you play with fake news and clickbaits and all of that, right? So that's, okay, I'll shut up. Are there any quick questions? Is it a big brain dump? But it's all yours to play with. You do what you want. So, oh, by the way, don't forget this. This is very, very important. Please make sure that you do stop your thing, because, you know, I don't know what will happen in the community edition. So you guys are running this in the community edition, right? Yeah. Trusted it works. And I'd also be a good, you know, I would also just try to clean up the directory. Yeah, so let's see. So, you know, you just, because it'll be difficult to hunt these things later if you don't know where it's written and stuff.